Dear students, today we will see about determination of mass moment of inertia using the axisymmetric turntable apparatus. So, stop. Aim of the experiment to determine the moment of inertia of unknown member by using the torsional apparatus. This is the block diagram of the turntable apparatus. So here we have the torsional rod and then sensor and then disc. So disc is attached to the top of the shaft and the base is attached to the fixed end of the rod. So apparatus required, experimental setup and then connecting rod and timer. So next we going to see about the formula used. So this formula we going to use to find the moment of inertia. So I1 is equal to q t1 square divided by 4 pi square. I2 is equal to q t2 square divided by 4 pi square minus I1. So I1 means mass moment of inertia of disc. I2 means mass moment of inertia of object. Next T1 is time taken for one oscillation of disc. T2 means time taken for one oscillation of disc with object. Next Q means torsional stiffness of the rod. So for this experiment we are using diameter of the shaft is 6.1 mm and length of the polish rod is equal to 660 mm. So next we going to see the tabulation of the experiment. For this experiment 3 trials we going to done and taken the time for the moment of inertia. So for 3 trials, the first one is disc without object. We take the time taken for one oscillation, and object means with the object we going to take the one oscillation. So for this 2 procedure we take the 3 trials. Next we do the experiment. So first we going to connect with the timer to the connection and then switch on the experiment. So now we rotate the without object for the finding the moment of inertia for the given rod. So first we going to slightly rotate the disc and then to release suddenly. So we got the reading for one oscillation 0.73. So same procedure we do the 3 trials and then second trial. So now we move slightly to rotate the disc and then release again. So now we got the different reading. So this is the second trial. So next we take the reset to the timer and then we take the third trial. So third trial also rotate the disc and then release suddenly. So we got the different reading for the third trial. So these 3 readings are not for the under the disc. So now we going to take the attach to the connecting rod on the disc. So we have the pivot point for connecting the connecting rod and then we tighten manually for the hand tight only. So this after connecting this connecting rod we take the 3 trials. So now the first trial we going to do that first trial. So first rotate the some distance and then release. We got the first trial reading for time taken for one oscillation and reset and then second trial we move or rotate the disc particular distance, and then second trial we got the reading and then reset the timer, and then third trial rotate the disc some distance or some angular displacement. Finally we got the third trial reading with connecting rod. So this is the reading for disc and object for the time taken. For now we going to do the model calculation for the given reading. So we take the I1 formula. I1 is equal to Qt square. So here T is equal to first trial 1 reading, that means T1. I is equal to Q is equal to 16.476, that means stiffness, torsional stiffness of the shaft. So torsional stiffness we going to calculate here. Q is equal to GI divided by L. G means polar moment of inertia, modulus of rigidity, and J is polar moment of inertia, and L is length of the polished rod. So modulus of rigidity G is equal to 0.85 into 10 power 11, and J is equal to 1.359 into 10 power minus 10 mm power 4. Here J is equal calculated from the pi by 32 into d power 4. D is wire diameter. So we got the J value is equal to 1.359 into 10 power minus 10 mm power 4. So from this formula we got the torsional stiffness value 16.476 Newton meter. So for this value we are going to use the I1 formula and I2 formula. So I1 formula we take the 16.476 into T square. T square means 0.82 first trial value divided by 4 pi square. So from this calculation I1 is equal to 0.2806 kilogram meter square we got, and then I2 formula Qt square divided by 4 pi square minus I1. So here same values we going to use. Q is equal to 16.476 into T2 means with the object 1.11 seconds. So finally we got the I2 value 0.2336 kilogram meter square. So this procedure we done all the trials, 3 trials. Finally we got the average value of the I, that means, so these calculations we done in all the 3 trials, and finally we got the average value. So this value is mass moment of inertia for the given rod. Next we going to result. So thus the torsional oscillation equipment is tested, and also mass moment of inertia of unknown object is found out. Thank you.